So beginning of chapter 2, let's have you try graphing the piecewise. Try and graph all 5. They are all lines. So if you start having curves and whatnot, you are doing it incorrectly. Okay. All right, let's take a look and see how you did. So all of these are lines. Again, negative x plus 1, and unfortunately I think when I tap the screen it's just going to put the whole graph up there. I don't think it's going to be just doing parts of it. But maybe, oh, we'll just do parts of it. Awesome. So, must be I was thinking ahead on this one. So you agree that's negative x plus 1, and how come I have a hole down there at 1 comma 0? Yeah, right here, the very first one. If all I'm graphing is the first one, it says not to include 1. Then the next one says it'd be y equals 1. Remember, that's a horizontal line, from 1 to 2. So again, you kind of got to know where you're going to have to tap, so I'm guessing right about there. Okay? You agree that's y equals 1. It's a horizontal line, but only from the x values of 1 to just short of 2. How about this one? This is a weird one. Y equals 2 only when x equals 2. That's just a dot at basically 2 comma 2. I hope that one's in there. Maybe. Find it. There it is. So it's a little high, isn't it? Well, not too bad. So 2 comma 2. Now we got 2 more lines. We got x minus 1. Again, the easiest way to do it is say for this one, just take 2 and substitute it in there. So what do you get? You get 1 and then put 3 and substitute it, well, not there, in there. And you get, just to agree, it's a line that basically goes from, what were the numbers you gave me? It was 2 comma 1 to 3 comma 2, right? Now where's the hole going to be on that one, though? Yeah, 2 comma 1. So you find 2 comma 1, so 3 comma 2, hopefully I find it. There it is. That's where that line would go. Again, all I'm doing is substituting those values in. It's not that complicated. Okay? So down here you do the same thing. Plug in 3, plug in 4, find out where that goes. And so it's 3 comma 2 and 4 comma 1. So there it is. Any questions how I arrived at that piecewise graph? Of course, I could ask you for domain and range. That's not what I'm looking for here. I like how this particular textbook talks about limits, and it's that first sentence I gave you up there. It gives us a language for describing how the outputs, which is usually y, of a function behave. You know, what are they doing? Are they going up, going down? Where are they going? As the inputs, which is usually x, approach some particular value. Okay, we're going to talk about that in just a second. Everybody got the graph down? Fairly accurate? Hopefully really accurate. All right. So this one right here is saying find the limit, and I probably should say, what did we call this thing? Just y? Well, anyways. So normally I'll say limit of like f of x or something like that because it'll define that function for you. This one I didn't have that, but because I know we're talking about the same graph. Do you see there's that little subscript underneath limit? It says as x gets closer and closer, that's what that means, 0, and then there's a little plus sign up above. All I'm doing is writing this bigger so you can see it. It's saying the limit as x goes to 0 or gets closer and closer to 0. The positive just means from the right. That's all a positive means. So let's take a look. If I'm right here, I'm getting closer, and now it's x is 0. Do you agree x 0 value is right here, correct? But this graph actually puts the y value up there, right? That's the output. So as my outputs, what is happening as I'm coming closer to x? Do you agree this is x of like a half, x of 3/4, so forth and so on? As you draw that closer and closer in here, what value is it going closer and closer to? You're looking at the output, the y value. It's getting closer and closer to 1. Okay? Because you're looking for the y value there. Okay? Really, it's just the limit equals 1. So you might not want to write y equals 1. Okay, any questions on that? Let's do another one. This one's saying as x gets closer and closer to which value now? 1 from the right. Okay. Again, I'm just writing it again because it's so small. So, well, where is an x value of 1? Do you agree it's kind of right in this area here? Right? So I'm going to go to the right of x value of 1. Well, where's the graph? It's right in this range, right? Somewhere in here. So as you keep going in from the right, do you agree the y value really isn't changing at all at this point? And I keep going, and I keep going, and I keep going, and I keep. Which one am I getting closer and closer to? I'm getting closer and closer to what y value? Well, 1. Okay. Now, did you notice I haven't been saying what is the y value there? I've been saying which y value am I getting closer and closer to? Do you understand the difference between that? Again, the y value doesn't even have to be there. All right. So now it's saying x approaches 1 from a negative. Well, what's that mean then? From the left. So you agree, once again, x value of 1 is somewhere in here, right? And so I'm supposed to find the graph that is to the left of that. Okay, well, where is the graph? Well, it's this little diagonal here, right? And so you find some spot on there. All right, right there we're going to start. And what I'm going to do is keep getting closer and closer and closer. I'm approaching from the left. Again, what y value am I getting closer and closer to? Not what is y defined as, but what am I getting closer and closer to? 0. Does it actually have to be there? No, I'm just saying, what am I getting closer and closer to? It's like that example of me going halfway to that wall every time. What am I getting closer and closer to? That wall. Okay? And the answer is? Now, notice this one. It just says as x gets closer to, you notice there's no plus or minus? That means 1 altogether. And the only time you can answer that question is when going from the right and going from the left are approaching the same number. Are those two approaching the same number? You see, notice how I did 1 from the right, 1 from the left, and then 1 overall? I kind of led you to that. Those two have to be the same number. If they are not, you cannot answer that question. And you flat out say, no solution. Okay? I can't do that because they're not going to the same number, basically because as I come from the right, I'm going to there. As I go there, I'm going to 2 completely different places. Now, if they come to the same spot, then you can answer that question. Okay, but this case, they did not. Yes?
So if it connected to the line, like what if they connected in between the 1 and 2 there? So like if, you know what I mean? Like it would just get from 1. So what if that line ended up going to 1?
This one here, you mean?
No, the other one. So what if that connected over to 1?
Like down here? Well, that wouldn't happen because you have 2 options for the limit. You mean this one's not here? Okay. You get 2 options then, and that won't happen. Okay. Good? Yes? No. Not the ones we're going to have. Nope. That's a completely different topic from calculus. So, good question. All right. Oh, now we're talking about 2. Notice I do from the right, then I do from the left, and then I do 2 overall. So let's find, well, where is x's 2? X 2 right here, right? So where's the graph? It's either, well, it's right there, right? Or right there, right? So first, let's do something to the right. Do you agree all these values are to the right? And I'm working my way in, right? So again, what y value am I approaching? Y value, not x value. Y value of 1, right? See, it goes up a little bit, and now it's working its way back towards what y value, because what's the y value about here? About 1.9, 1.5, 1.2. It is working its way towards 1. Now, is the answer always 1? No. Okay. Yes? You have to follow the graph that you have. Yes. Yeah, there's nothing that goes towards that, if that's what you're wondering about. And that's why I put that point in there. Because does the graph really lead you to that point? It doesn't. That's just out there on its own. And that's why I put that one in there to see what you would ask. It's a good question. Yeah, there is a hole right here at what, 2, 1, but that doesn't matter. You follow kind of the road. You could look at it that way. It's telling you where to go. And it's leading me towards 2, 1. And here's the 2 part of 2, 1. You have to put the y value over there. Okay. So same thing here. It is 2 from the left. So let's talk about that. So let's go to the left of 2, because 2's right here, so let's go to the left. We're here, and we work our way in. And what are we getting closer and closer to as a y value? Well, we're 1 the whole time, and so we're getting closer and closer to 1 again. So can I answer letter G now? Because they are both approaching that same value. They're both coming right there, and so 1 is the answer. Yes?
For F, why isn't it like the
You could do that. You could start here and say, I'm coming on in, and here we go. Whoop, it went up here. Okay. It just goes and follows the road. It was like maybe teleportation right there or something. All right? The dot at 2 comma 2, that is a defined point. It is part of this graph. But do you think that that point's ever going to play a role as far as a limit? Can the limit actually be 2, though? Now, what would we have to, and that might be the next one, who knows? And it is. Let's talk about the next one. Limit as x approaches 3 from the right. So you got to find an x value of 3 and go to the right of it. Where's the graph? It's right here, right? So somewhere in there. And so you work your way back towards it. What y value am I getting closer and closer to? It is. Now it actually is defined this time. That's fine. It doesn't matter. All right? It's 2. How about, let's do from the left green this time so I don't have to keep writing these in there. So you take something to the left of 3. Could you start way over here? You could, so you follow it along. This is a waste of your time, but then you hop up here, then you hop over here. So as you keep going, you're getting closer and closer to what? 2. Right? So can you answer the limit as x approaches 3? What is it? 2. These two, yeah, coming from the left and coming from the right, if they're the same number, see how these are both going to 3 from left and right? If they match, if the answers match, then the whole limit is 2. Where in the first one, they didn't match. It was like 1 and 0 for the first one. See here, from the right, from the left, they didn't match. And so you couldn't answer that question. Yep. How about the limit as x approaches just flat out 4? How would you say no solution? Yes. Is there a plus or minus on letter K? No. So you need to approach from both directions. Can we? There's only one direction, so can we even do that problem? No, you can't. We don't have both directions. Now, I chose a piecewise just to have you practice that again, and I wanted to get that point just hanging out there. That's pretty much the limit process. What are you getting closer and closer to as the x gets closer and closer to the value it's asking? What does y do? Okay. As the statement says on yours, it can be easy to determine limits graphically once you're comfortable. But many times it's easy just to substitute. It's easy just to substitute if that particular graph happens to be continuous where you're being asked. And I'll explain that as we go. For example, do you agree that this function is way easier than the function you had in the first example, which was that? Much easier, right? Big 5 piecewise function there. This is just one very simple function. We know what that is. We know what that is graphically. Okay? But what we have to do, and all we have to do then in this one, because let's face it, are there going to be any holes or anything like we had in our last piecewise graph in this graph? No, that thing just, it's continuous, right? There's no jumps, nothing in that thing, right? So if that's the case, you can just go ahead and substitute that value right in there for x, and it will tell you the answer. Okay? And so what's the answer to this one? Now let me show you why. Do you agree? That's pretty much the graph. And we're talking about x being 1, right? So we're looking at what happens as you come from the right, what happens as you come from the left. Are you going to the same point? What does that y value happen to be? It happens to be 5. Well, yeah, I'm over here. See, 1, 2, 3, 4. It would go up a little bit. Okay, see? 1, 5. Okay, that's why you can just substitute it in. It's simple. How about this next one? Can you substitute it? You sure can. And what do you get? 2, yeah, because it'd be 4, right? Over is. Now let me show you this graph. I want to make sure I have it right in my head. And I do. This is something that we talked about in advanced math. We will revisit this next. You do not have to be able to graph these this quick right now. Okay, there's the graph. And so we're here at x value of 2, and here's 1, 2. Right there's the point. As you go from the right and from the left, are you approaching the same value? Yeah, because it's continuous. There's none of those big holes and all those lines all over the place like we did in the piecewise. Much easier, right? So how about this one? Can we substitute? That's a -3, by the way. It's x approaches -3. Just the computer didn't really want to do that very well. So I actually didn't say no. I asked.
No.
Now, if it was a +3, yes, we would have a problem. If it was +3, why is there a problem? It'd be over 0. But there's not. It's -3, so no big deal. So you can go ahead and do that. And what do we get? You got to put -3 in every single spot. 9 over -6, yep, which is -3 over 2. Okay, once again, you don't necessarily need to remember how to do these right away. There's your slant asymptote. There's your vertical asymptote. You've done these. Well, I think some of you use different colors, yeah. So as x approaches -3, ooh, that's out there a ways, but so it's out here. Are you approaching the same value? From left to right? Yeah, you are. It's continuous where I'm asking you. You don't need to know how to get the asymptotes yet. I'm just showing you the graph to prove it to you. Yep. I'm showing you that it's continuous right there, so it's just substitution. That's what you need to gather from this. Okay, same deal. Can you do D? Yeah, it's a square root of 5. Is it a nice answer? No, but it still works. Again, this is just a parent graph, so what should I do to the square root of x? Half a curve, right? But where do I got to move it? Left 5, very good. And again, as x, here's x being 0, right? So find from the right, from the left. Am I approaching the same value? Yeah, I am, because it's continuous right there. The point's there. The other ones were harder because some of those points weren't there when we did the piecewise. Okay? And guess what point it is? It's square root of 5. How about this one? Yeah, that's a problem. Yeah, it's over 0. That's a problem. So substitution's not going to work. You can still do the problem, but substitution's not going to work. And how about this one? Yeah, it's imaginary. So does substitution work? No. So what I would say as far as the directions go, right, not possible. All right, so not possible by substitution. And just put, divide by 0. That's a pretty common abbreviation for that. Your calculators probably have shown you that sometimes. And then this one here is not possible by substitution again. It's not that it's completely not possible, but not possible by substitution. I have 2 dots on my eye for some reason. Because, yeah, imaginary. Okay. Again, I'm not saying they aren't possible altogether. What's that? If you put -2 into the denominator, you get dividing by 0. And dividing by 0 is bad no matter what. Okay. And, oh, look at that. Hopefully you determine that examples 2, E, and F can't be solved by substitution. Well, how do we solve them then? I think I will. Now, some of this, let's do the one on the right first. Because I can talk about this one very quickly graphically. Because it's just a parent graph, right? What are you going to do with that parent graph? No upside down. Limit as x approaches 0? Okay, when it's inside, it's opposite of what you think. Move it right or left. So right 5. Okay. Limit as x approaches 0. There's nothing even over there. How are you supposed to do that? So what are some limits that you could actually calculate on this one? Limit as x approaches, can't do 5. 6, how come you can't do 5? It's only one direction. All right. How about 6? 7, 8, you can do all those. And look at that. Can you just substitute those values in and get something? You can, because these graphs are continuous, at least where I'm asking you. Now this one right here. I'm going to see how many of you kind of remember this. Let's see how many of you can factor that for me right there, right now. Factor that numerator, please. There we go. So multiply to b. Add to b. Again, do such numbers exist? They might not. 3 and 2? All right, so if we factor the top, let's just leave this whole limit deal on here as x approaches -2. You're going to find out why that was a problem. Some of you, again, have never maybe seen this before, and some of you it's been a very long time. We are going to revisit all of these things, but I wanted to prove something else to you today. There is a 1 out front, so I'm going to use the shortcut if you don't mind. We could do the pants. It would work. Yeah, does anybody remember? Do you see how these factors cancel? Does anybody remember from advanced math what that means? It's called a removable discontinuity because I just removed it. But we called it something much easier than a removable discontinuity. A hole. There is a hole at x equals -2. Because you set whatever it is you crossed off equal to 0. Do you agree I would get x equaling -2 then? And all you have to do is graph this now. Graph x plus 3. Do you agree that's a line? But there's something wrong with my graph. My graph is just of that. Yeah, there should be a hole at -2. So x being -2, what is it, -2 comma 1? Whoops. We'll fix that. Yeah, the hole got a little big. Now do you see why substitution wasn't going to work? Because that point, the one point I was asking you about was where the hole was. And the function didn't know what the y value was, so it couldn't give it to you. But can we actually figure out this limit now that you see the graph? Is it approaching the same value from both directions? It's approaching 1. Okay. So the answer to that one is 1. Again, if you don't remember the whole thing, that's fine. We're going to revisit that. But I wanted to show you that if they're continuous, this is actually quite simple. Yeah, the other one there, for the problem that you have over there, there is no solution. But again, if we change it to the limit as x approaches 9, well, you can do it.